Over here, we'll seek to understand why for SN1 reaction, we like to use a polar protic solvent. Now let's consider what makes an SN1 reaction mechanism. Let's go back to the basic. It says here tertiary alkyl halide. So I'll give a tertiary alkyl halide. Remember the fundamental of this nucleophilic substitution. Unimolecular says that in the first step, the slow step is merely the self-dissociation of the leaving group, and you form this carboxylic ion. In this case, you have a tertiary carboxylic ion, which is very stable because of all these electron donating R groups that push electron density towards this C+ and suppressing the positive charge. Don't forget, you also eject the chloride ion as a leaving group, but chloride ion has lone pair of electrons. So it's possible that this chloride leaving group can attack this carbon again and reform my starting material. That's why the first step, there's a speed of equilibrium, it can go back. What we really want is for the reaction to stay here, so there must be some driving force. Of course here, one of the driving forces is having more R group. R group means you can push electron, lower C+, stabilize this. And that's why we always encourage the tertiary alkyl halide. Another factor could be more external, using solvent that's polar protic. Remember polar protic solvents? They must have bonds such as OH, right? They can form hydrogen bond, delta minus, delta plus. So why is it the use of this kind of solvent help to stabilize this carboxylic ion? Just imagine this is my C+, and here we have this polarized bond here, delta minus on this oxygen, that's lone pair of electrons. And I can put one molecule of this alcohol solvent right here, one molecule over there, another molecule over here. And what happens? This lone pair and partial negative charge of the solvent alcohol could get close to this carboxylic ion and stabilize it, suppressing the carbon positive charge. So in a way, it helps the reaction because it lowers its energy and keep it here. So that in the next step, which is a slow step, we have the nucleophile. That's when it will come in and attack the carboxylic ion center. Now you might think, in polar aprotic solvent, we could have a tetrahydrofuran. So isn't this oxygen also delta minus? There's lone pair as well. It's true. But the thing is, this oxygen connects to what neighbor? Carbon-carbon. And carbon is not as electropositive compared to hydrogen. So that's why this delta minus charge is not so strong compared to a delta minus charge of the oxygen in the alcohol. Which means that this effect where you put the oxygen of THF around this carboxylic ion is not so effective. So by this virtue, we know that those with NH bond and OH bond in the solvent can work likewise and use its lone pair of these heteroatoms from the oxygen or the nitrogen here to surround this carboxylic ion, C+ here, and stabilize this. So that's the reason why for SN1, we prefer to use polar protic solvent.